Hello and welcome back to Differential Equations. It's the exam review day. So technically just we do nothing, right? Sit here for 30 minutes and leave. So what's on the test? That's simple. Problems and hopefully your answers in blank spots. I would say about 10 problems should be okay. And about hour 20 minutes, which is the norm. And the content, so chapters 1 and 2, and then up to 3, what do we say? No, we are in chapter 2 now, right? So 2.4. So chapter 1, all. Chapter 2, 2.1, 2.4. Great. So what are the important highlights? Know how to classify ODEs. Now what does that mean? You need to be able to say this is the first order, this is the second order, this is the seventh order differential equation. You also need to know what's linear, what's nonlinear. You also need to know what's homogeneous and non-homogeneous, right? So you have those classifications that will be in one of the problems. We'll just say state what type of differential equation you have, and you just write next to it, maybe A and B, like two cases. The next part, so will be working on separable differential equations, right? You need to know separable differential equations. Now, guys, remember you're integrating both sides. So integration techniques include vanilla integration. Then we have U sub, trig sub, by parts, partial fraction decomposition. So if you are to kick one of these out, which one would you kick out? You want to kick out partial fraction decomposition? I was afraid you're going to say that. Like trig sub is like 5 times worse than that, and you need partial fractions for your. Oh, get rid of trig sub. So definitely no trig sub on the test. All right, I see how it goes. All right, fine. That's what happens when you skip Calc 2 class and you land in differential equations. Just like everyone's like, yeah, trig sub, and it's one student going. All right, great. So separable differential equations, I'm just going to say over here, no integration. Awesome. We have our slope fields. Right, so draw the slope field. Right, and solution curves. Now we have the word problems. Which deal with population and so on. So this is usually separable equations. They're talking about population. You're talking about Newton's law of cooling and that kind of stuff. Nothing spectacular. All right, so now we're getting into first order linear equations. So this is where you are. Which method? What is called? Exactly. Very good. Integrating factor. Very good. Okay. Obviously, you can go back on the YouTube channel and find every lecture if you forgot the procedure for integrating factor. That's you multiply by the integral of e to the p dt, and then you collapse it into the product rule and integrate both sides, right? So know your integration. So that will be integrating factor. So then we have substitution. Generally, you are looking into, I'm actually inclined to give the substitution. So you just grind through algebra. But if I skip this part, you have the part on exact equations. Now that one is important, okay? So exact equations is the one that it's important. That's with partial derivatives. If you remember the dm over d, right? dm over partial m partial x partial y, sorry, is equal to partial n partial x, and then it's the same thing like potential function from your calculus 3. You have the population stuff. That's the word problem, so I'm not going to list that again. Acceleration velocity, again, same stuff as before. And we ran out of stuff in chapter 1. Now, the chapter 2, I'm not going to put the proofs or derivations or any of these things. You know that the superposition of the solutions, right? You come up with the two solutions, you add them up together with the coefficients. The Wronskian. So let's see exactly what we have. Okay, so second order ODEs, which branches into, so second order ODEs, you have to know independence of solutions, which means check with Wronskian, right? So independence of solutions. I'll put Wronskian in parentheses, that way you don't run into issue. Independence of solutions, and then well, actually that's it. Now we go with the second order linear ODE with constant coefficient, which would give us those three possible, right, distinct roots. R1 not the same as R2, which gives us y equals C1 e to the R1t plus C2 e to the R2t, or x, whatever. We have repeated, which is R1 equals R2 equals just R, in which case we have C1 e to the RT plus C2 t e to the RT. And we have complex conjugate pair. R equals A plus minus BI, in which case the solution is e to the AT cosine BT plus sine BT. I forgot the coefficients. Back to the drawing board. C1 cosine bt plus C2 sine bt. Much better. So that's the constant coefficients, and that leads us into the last section, which was just mechanical vibrations. So a word problem where you, so word problem again, mechanical vibrations. We are talking about knowing two equations here. One of those is the mx double prime plus the cx prime plus kx equals to 0. So for mechanical vibration, you have mass is important, the dampening constant c is important, and k spring constant is important. So plug all of those. Those are numbers, right? So this ends up being the homogeneous second order, right? Constant coefficients. You just unleash the method of, right, characteristic equation. You're done. So that's one, and the second one is the one with the frequency. We could, but we don't. Whatever. So that's the first one, and the second one would be the good old x double prime plus omega 0 squared x equals 0, where the omega 0 is square root of k over m, and whose solution is that good old x of t equals to c cosine of omega 0 t minus alpha, the phase shift. C is the amplitude. Omega 0 circular frequency. That's angular velocity. And then phase angle. Off of this case, the period is 2 pi over omega 0, and off of that frequency, ni, is omega 0 over 2 pi. Period and frequency. You ask someone how frequently do you go grocery shopping, they will say once per week. That's 1 in 7. So you should kind of be able to get those quickly. And that's it. I hope you're not disappointed, but that's all we have. Well, the only thing that you are actually learning in this class is how to come up with the equation. When you're given an equation that's a pre-calculus 1, that's not even calculus, right? You learn in 3.5 in pre-calculus 1 how to plug in and compute equations in terms of ln both sides and stuff like that. What we learn in differential equation is exactly what we did. I think we did that on day 1. Let me just skip yes here. So where I said this is how we transfer words into equations. So separation of variables. I did here. So this is exactly what we are learning. So change in population, right, is proportional to population. So if you go back and watch the first lecture, then I believe also 1.4 might have it, and then 1.7 might have it. The goal of this class is how to translate the language into equation, which is differential equation, and then separation of variables will take care of it for now in terms of this. So your focus should be on how to change the words into differential equation, and then from that point on, in 99% of the cases for this test, right, it's going to be separation variables. Fair?
You'll tell us the change in hydration is proportional.
Yeah, so change in temperature is proportional to the difference of the temperature and the room temperature, in which case, right, the word difference is subtraction, and then, again, it's separable equation. So the language of it is always clear because the word change immediately triggers the derivative, and then whatever you pick to be variables for the rest. And we did, I think, at least 5, 6 examples of that throughout different lectures, so you should be able to pick up quickly. All right, so questions, concerns. In the past, what I found the most lacking in terms of students doing the test would be integrating factor and exact equations. Both of those are procedures. So please pay attention to those. Make sure you can do them. They have to be on the test because that's what you're learning now, right? Sure, you know, if the algebra and calculus get in the way, it's an issue, but it's not as much issue if you mess up on integration as much as it's issue if you don't know what the integrating factor is and you don't know the formula e to the right integral of, because you can't do it, right? You can know all Calc 1 and all algebra you want. If you don't know the formula for differential equations, then clearly that's a big problem. Again, if you don't know algebra and count to integrate, this is a problem, but it's, I would say, lesser problem in differential equation. You shouldn't ideally know everything. So pay attention to that. And then the procedure for exact equations. You have that condition, right, that the partial derivatives have to match. And if you have that situation, you can go and do the procedure for that. Do you remember that at all? The exact equations? Right? M and N, yes, M and N. So you first check the exactness condition, and then you integrate. So that one, usually, as I said, that's the largest kind of hurdle to overcome, the exact equations and multiplying and integrating factor. The rest, constant coefficients, I mean, that is characteristic equation, and I hope you can factor, right? You are memorizing 3 different cases, right? Different possible answers, which is distinct roots and then repeated root and then complex roots. They all have different type of the solution. What we studied today, the undetermined coefficients, are not on the exam, okay? So don't kill yourself tomorrow over learning that. We're going to put that on the next exam, along with power series, kind of balance. It's okay, that test only had 3 problems. It's not an issue, right? It's a 1 power series problem that then there for an hour, and then 2 other problems, 10 minutes each, hour, 20 minutes. There you go, done. Exam 2 easy. Right?
You don't know more than 66% right off.
Yeah, you're right off. Like that's 80%. Okay. Good. I'm just trying to see if there is anything else that we left out. In terms of slope fields, try to be as neat as possible. I mean, if you have 2 colors, that's amazing, because you can use 1 color to draw the slope field and then another color to draw the possible solution going through the slope field. Remember that slope field is for first order equations where you have that derivative, right? The y prime is actually the slope, so you are setting that to be 1, setting it to be 2, right? And that's the steepness of the line that you draw on the function that you get. Classification, again, make sure. Wronskian and dependence, anyone remembers that stuff? Yeah. And that's when we have to fix it by multiplying by t or t squared or whatever we need. And we'll see much more of that next class after the test when I go into the second part of today's lecture. Good. And mechanical vibrations, again, you have the mass is 5 kilograms. Put that to the spring. It's going to be 5 and negative 3 and 7. Right? We're kind of looking for solutions over there that are complex, right? Because if something is dangling, right, it should have periodic solution with e to the minus something, so it stops, right? So that kind of these problems, you know, to make physical sense, they have to have that complex solution from the three possible cases that you see. And again, the reason is the sine and cosine is what makes it oscillate, right? And e to the minus 3t is the one that makes it die, right? Eventually, so it's not moving anymore. I had that. That was the last graph that I drew, right? So when you take something that's hanging on a spring, you pull it down and let it go, it's going to go like this, and then it's going to, throughout the time, right, stop and then stay at the level. So that's when it dies out, which is when e to the negative t, right, the values of t, right, enough time passed, so that term became dominant and just killed everything. I think that's it, unless you have some questions, suggestions for possible more material to be added, or any wishes to be granted. So no trig sub. Yeah, sure. So integrating, let's take a look at the integrating factor. So what you see on the screen is something that you will hopefully not memorize, right? But you can literally write out your solution to the first order linear equation if you memorize this formula. Then you don't have to know any of the steps for integrating factor. You would literally plug in your p of x and q of x into this formula, and the general solution will just pop out. If you are working on the equation, the first order linear equation has to be in this form. I can actually just add over here, what the hell, there we go. That's y prime plus, wow, I have a y missing over here. P of x, y, holy nightmare. I just noticed that there's a y missing in here. Wow. Well, that messes everything up. All right, so we're looking at 1.5. I will find an example in 1.5 homework. The good thing is that you're reading the book, not listening what I'm saying, so that's why you're all great with this stuff. So in factor, integrating factor, there we go. I don't know, any of these equations are really nice. Let's try 6, see how it goes. xy prime plus 5y is equal to 7x squared with y of 2 is 5. So we have to get it in the form like this. Clearly we are dividing by x everywhere to get y alone, y prime alone. So that's going to be 5 over x, y is equal to just 7x on the right hand side. And we see that p of x is 5 over x. So now we are going to, I don't know, what was the letter that they used? Rho? Rho. It used to be mu. The hell? Okay, so rho of x is e to the negative integral of p of x dx. So that's e to the negative integral of 5 over x dx. Now we all know that that's what? What's the integral of 5 over x? ln. So we have e to the negative 5 ln x. And now this negative 5 will be the exponent of this. So rho of x is going to be e to the ln of 1 over x to the 5, like this. And then e and ln will annihilate each other, leaving just 1 over x to the 5. So rho, which is the integrating factor, is 1 over x to the 5. Now we will multiply our differential equation through with that rho. So we'll have 1 over x to the 5 times y prime plus 5 over x to the 6 when you combine them. Y is equal to, on the other side, 7 over x to the 4th when you multiply through. And we know that this has to be f g prime and then g f prime. No, f prime and g. There we go, much better. So now we condense this into 1 over x to the 5 times y, that's the derivative, is equal to 7 over x to the 4th. We integrate both sides to get rid of the derivative on the left hand side, and we get 1 over x to the 5 times y is equal to, right, this is dx over here. So when we integrate this, we get what? Anyone? Can anyone integrate 7x to the negative 4? Or we're just doomed in 2 days? Doomed? Yes. So it's, you add 1, right? So it's going to be 7x to the negative 3 over negative 3. Good. So that's negative 7/3. And then there is x cubed and the bottom plus some constant c. And to fish out y, you will multiply both sides by x to the 5. So y of x as a general solution is going to be x to the 5 times negative 7 over 3x cubed plus c. Now you can actually distribute that through and get negative 7 that cancels, so it's going to be negative 7/3 x squared plus c x to the 5. We did have initial condition that y of 2 is 5. So we can plug that in and calculate the value of C. So I'm going to box this one and say that's a general solution. So we all know that. And now I will plug in initial conditions. So y of x, that's a 5, is equal to, and then you have 2 squared of 4, negative 28 over 3, plus, and then 2 to the 5 is 32, 32c. From where you can calculate c, if you know. That's 15 and, what's 15 and 28? That's 43 over 3 is equal to 32c. So c is equal to, 32 goes this side, 43 over 96. So y of x is equal to negative 7/3 x squared plus 43 over 96 x to the 5. And that will be particular solution, because it goes through 0.25. And the one on top is general because of this c, which could take any value. Happy? Of course, differential equations, right? That's why we're all here, happy. Anything else? All right then, I will see you all in 2 days for the